So we'll see how to calculate eigenvalue and eigenvectors for a given matrix. So yes, suppose you have a small matrix. Let us start learning from a small 2 by 2 matrix, 2 1 0 3. Okay, I have a matrix A equal to 2 1 0 3. Why you need eigenvalue, eigenvector? We need this in different solving different problems. Like I will give an example. Principal. I told about principal component analysis. For this, you need to form covariance matrix. You want to have covariance matrix with the data what you have. To form covariance matrix, I need to calculate eigenvectors. To get eigenvectors, I have to find out eigenvalues. And where is this PCA used? It is used in dimensionality reduction. Dimensionality reduction. Why we need dimensionality reduction? Because we have to reduce the size of the data set. Mostly we use this in image processing. Somebody working in this area, so this is the channel. You should know how to calculate eigenvalue, then you eigenvector, then calculate covariance matrix, then you apply PCA technique, you do dimensionality reduction. That is used here. I hope you understood why are we learning eigenvalue, eigenvector calculation, and how it is useful in machine learning algorithms. So let this simple example, A equal to 2 1 0 3. This is a 2 by 2 matrix. I want to calculate eigenvalue first. How do we calculate eigenvalue for this given? I am starting with a simple example. So you have to find out A minus lambda I modulo equal to 0. First step is this. So determinant of A minus lambda I equal to 0, right? So let us do this. You have 2 1 0 3 minus lambda into I stands for identity matrix 0 1. Okay, so A minus lambda I, this determinant I have to find out. So this will become 2 minus lambda 1 0 3 minus lambda. Okay, 2 minus lambda 1 minus 0 0 minus 0 3 minus lambda. So this is my A minus lambda I. Now find out determinant for this. So you have to find out determinant for this. So if I find out determinant, you know how to find out. Just AD minus BC determinant you find out. So 2 minus lambda into 3 minus lambda minus this one equal to 0. Just converting into system of converting into a equation. So if you multiply this, 6 minus 3 lambda minus 2 lambda plus lambda square minus 1 equal to 0. So this becomes lambda square minus 5 lambda, I think, plus 5 equal to 0. Lambda square minus 5 lambda plus 5 equal to 0, right? Where I did some mistake here. Yeah, this is 0. Correct. Sorry. So this changes here, right? Equal to 0. I then need not calculate this full equation. We get the eigenvalues directly here. So lambda value is 2, lambda 1, lambda 2 equal to 3. Okay. So when you find out A minus lambda equal to 0, you get two eigenvalues, lambda 1 equal to 2, lambda 2 equal to 3. These are called eigenvalues. Okay. Given a matrix, convert into A minus lambda I, solve that determinant, solve that equation, find out the values for that equation, lambda 1, lambda 2. So you get two eigenvalues for this matrix. Okay. Now when you have two eigenvalues, how do we calculate eigenvector? I am explaining for a 2 by 2 matrix. Slowly we will see for 3 by 3. Now how to find out the eigenvector for each eigenvalue? So there are two eigenvalues, right? Lambda 1 and lambda 2. For each eigenvalue, we will have one eigenvector. So let us find out what are those eigenvectors. Okay, so how do you find out that A minus lambda I x equal to 0? Okay, so this is 2, this is 3. Now you substitute here, we had our A minus lambda is like this, 2 minus lambda, 1, 0, 3 minus lambda. we had this into x1 x2 equal to 0. Instead of now we are trying to find out eigenvector for lambda 1, eigenvector for lambda 1. So what is lambda 1 value? 2. Substitute 2 in this lambda, so the matrix becomes 0 1 0 1 of x1 x2 equal to 0. Okay, so I substituted 2 here. 2 minus 2 0 1 0 3 minus 2 1 equal to 0. So we get x1 x2 as 0 0, both the values as 0 0. So the eigen vector for given eigen value lambda 1 is 0 0. Okay, same thing let's do for 2. So for eigen value for 2, second eigenvalue, let's find out eigenvector for second eigenvalue. So eigenvector for lambda 2 will be, substitute 3 here. So 2 minus 3 minus 1 1 0 0, x1 x2 equal to 0, some values x1 x2. So again if you solve here, right, again if you solve here, let's what is this equation becomes minus x1 plus x2 equal to 0. So maybe x1 equal to x2. When x1 equal to x2, it can take any value. If you take x1 as 1, so that 1 can be the eigen value for this. If you can take x1 x2, you can take any value, but we have to generalize it. So let's take 1. If you take 1 1 value, so eigenvector becomes 1 1 here. Okay, 1 and 1. So you find out eigenvector this way. X2 is 0, but x1 can take any value. Previous case, 0 0 1, 0 into x1 x2 equal to 0, 0 into x1 x2 equal to 0. Yeah, both cases x2 we are getting as 0, right? Yeah, true, I missed this, I thought, right? So in this case also it will be 1 here. X2 x1 become 1 because x2 is 0, x1 can be anything, so it will be 1. So 1 0 1 1 will be the eigenvalue. Let's solve more examples. Let's solve one more problem and see what are the eigenvalues. Let us take 9 2 4 3. Okay, I have a matrix 9 2 4 3. I want to find out eigenvalue and eigenvectors for this. So how do I find out? I have to find out determinant. So I'll directly write the equation: 9 minus lambda 2 4 3 minus lambda. Then this becomes for me 9 minus lambda into 3 minus lambda a minus 8 equal to 0. If I solve this, 27 minus 3 lambda minus 9 lambda plus lambda square minus 8 equal to 0. So equations become lambda square minus 12 lambda plus 19 equal to 0. So do we get here real values here, eigenvalues? I don't think. Can we get real values here, eigenvalues? Solve this, use some online calculator and see what is the value. I don't think we can express this. We cannot solve this. So we cannot find out eigenvalue and eigenvector for this because we are having yes, right? So it's difficult to solve. We are getting some complex values. So for complex values, we cannot calculate the eigenvalue and eigenvector. Let's take a 3 by 3 matrix now. Let's take a 3 by 3 matrix, try to find out its eigenvalue. Let me take an example. So let's take a 3 by 3 matrix, try to find out 2 3 0 2 3 0 1 4 3 0 0 1. Let's try to find out eigenvalue for this. Eigenvector calculation is we have a different rule called Cramer's rule. We'll see with that. You need not solve it using by substituting equations because again it becomes difficult. So we have Cramer's rule for 3 by 3 matrices. We can apply Cramer's rule. Let's see how we can do this. So you have matrix, again you have to find out determinant. A minus lambda I equal to 0. So the matrix becomes 2 minus lambda, 3, 0, 1, 4 minus lambda, 3, 0, 0, 1 minus lambda. If you can solve this determinant, what is the equation you get here? Maybe 2 minus lambda into this I am considering, so this minus this. So it is 4 minus lambda into 1 minus lambda minus this, right? So we have 0 in here, minus 3 into, so 1 minus lambda, that's it. Again, 0 means this term, it is gone. Even if you multiply with 0, it is nothing here. So this is what you get here. So if you multiply these things, 2 minus lambda, and here you get 4 minus lambda minus 4 lambda plus lambda square minus, if I just open it, it becomes 3 plus 3 lambda equal to 0. So again multiply this. So you have here lambda square minus 5 lambda plus 4 into 2 minus lambda minus 3 plus 3 lambda equal to 0. If you solve it more, you can find out, since we have the calculation directly, we get two values of lambda 1 equal to 1, lambda 2 equal to 5. We don't have third eigenvalue here. We get only 2 because it is 1, 1, 5. So we get lambda 1, 1, lambda 2 as 5 because 1 is repeated here. Lambda, we get three values, right, for this if you solve. So all three will be 1, 1, 5. So we take only 2, 1 and 5. Now let's apply Cramer's rule here. Let's apply Cramer's rule and try to find out what are the eigenvectors for these eigenvalues. Okay, so that's the easiest way. Otherwise, you have to solve these three equations. Again, reduce row echelon form, find out the x1, x2, x3 values, which is time-taking process. Cramer's rule is a shortcut which can be applied. So we know that one eigenvalue is 1, second one is 5. Now let's apply Cramer's rule. Okay, how to find out this eigenvector using Cramer's rule? See, substitute, let us find out for eigenvector for lambda 1. Okay, so substitute 1 in place of lambda here. The matrix becomes 2 minus 1, 1, 3, 0, 1, 3, 3, 0, 0, 0. This is my matrix and I have x1, x2, x3. Okay, so if you multiply, you get three equations here. If you multiply, you get three equations here. What are those equations? 1 into x1, 3 plus 3x2 equal to 0, first one. Then 1 into x1, 3x2 plus 3x2 plus 3x3 equal to 0. Third one, we don't have anything. For third one, we don't have anything. So it's direct here. We can solve from this. So I think you understood now. You have two equations like this. You have two equations now. Third one, we don't have. You have only two equations. How do we apply Cramer's rule? Okay. See, I will just erasing this matrix now. So just write x1, x2, x3, like this you write it. Now when you consider x1 term, when you actually, you see here it is 0 into x3, right? 0 into x3 equal to 0. Okay, it is 0 into x3 equal to 0. So when you are finding out x1 value, ignore x1 coefficients. Ignore x1 coefficients. Take other two coefficients. So I have to find out determinant of x2 coefficient is 3, x3 coefficient is 0, x2 is 3, and x3 is also 3. Now again, under x2, leaving this x2 coefficients, take coefficients of x1 and x3. So it is 1, 1, 0, 3. Okay, why 0 and 3? 1 because there is no here 1, 1. When you're considering x3, leave x3 part, take x1, x2 values. So I'll get 1, 3, 1, 3. That's it. Okay, understood? We'll see one more. We will try to calculate for lambda 2 equal to 5 also. Eigenvector. I hope you understood. You write x1. Under x1, you find out a determinant of which one. Take the coefficients of x2 and x3 when you are finding out value for x1. Okay. Now, what is determinant of this? 9 minus 3. 9 minus 0. It is 9. Here 3 minus 0, it is 3. Here 3 minus 3, it is 0. So 930. So under x1 we have like this, x1 by 9, x2 by 3, x3 0. Can we still reduce this? Yes, we can more generalize this. How we can generalize this? By dividing by 3. So this becomes 3, this becomes 1, this becomes 0. So the eigenvector for eigenvalue lambda 1 equal to 1 is like this, 3 1 0. Okay, I hope you understood how we are trying to find out eigenvector using Cramer's rule. Okay, let's try to solve it for lambda 2 equal to 5 also. Let's find out those equations and find out the eigenvector. There are multiple ways of finding eigenvectors by eigenvalues. One way is by solving system of linear equations. Again, it will take much time. So this is one shortcut people keep using when they write competitive exams, Cramer's rule. Right. So let's now substitute lambda 2 equal to 5. So what does my matrix becomes? It becomes 2 minus 5 minus 3, 3, 0, 1, 4 minus 5. It is minus 1, 3, 0, 0, 1 minus 5. It is minus 4. So you have equations x1, x2, x3 equal to 0. If you can solve these three equations, you get the value directly. Sometimes maybe without applying Cramer's rule also, you may get the values by solving the equations also. So yeah, so if you find out the equations, it is minus 3x1 plus 3x2 equal to 0. Second one, it is x1. I'm multiplying this 1 with x1, minus 1 with x2, 3 with x3. So 1 into x1, x1 minus x2 plus 3x3 equal to 0. Then 0, 0, 0 minus 4x3 equal to 0. So from here it is clear that x3 equal to 0. I'm not applying Cramer's rule also. Sometimes directly we are getting x3 is 0. Then here also if you substitute x3 is 0, x1 becomes x2. x1 equal to x2 and x3 is 0. x1 equal to x2 and x3. Here also you can solve this. It is equal to 3x1 equal to 3x2. Therefore x1 equal to x2. If you take x1 value as 1, so the vector becomes 1, 1, 0. Simple. Yes, we got right values. The eigenvector for corresponding eigenvalue lambda 2 equal to 5 is 1, 1, 0. Okay, I hope it's clear. One problem you try to solve and tell me what are the eigenvalues and eigenvectors for a given matrix. Solve this simple problem. I have all ones here. Can you take pen and paper and solve and tell me what is the eigenvalue and eigenvector for this given matrix A? Please solve. You write any placement exam for machine learning related. I see from my students when they write some online exam for the OT written test, when they write on especially on machine learning job roles, they are asking these kind of problems. Find out the eigenvalue, eigenvector. It is very important, and in interviews also they are asking it, right? So given matrix A, how do you find out its eigenvalue? So you have to find out determinant. Let's find out the determinant value. Yes. So I will write the matrix here. 1 minus lambda 1 1 1 1 minus lambda 1 1 1 1 minus lambda. How am I getting this one? It is same A minus lambda into identity matrix, this modulo. Okay, if you do this, you get this. Now try to multiply this. So it is 1 minus lambda whole cube. Oh no, sorry. We have tried it. 1 minus lambda into this minus 1. So it is 1 minus lambda whole square minus 1. Next minus 1 into when you are considering second one element, so you have to take minus symbol and you have to take the other things. So this becomes 1 into 1 minus lambda. So it is 1 minus lambda minus 1. Next plus this 1 into 1 into 1 1 into 1 is 1 minus lambda 1 minus lambda equal to 0. So if you solve this is somewhere 1 minus lambda into 1 minus lambda whole square minus 1 minus, you see 1 minus 1 goes, minus of minus lambda becomes plus lambda, plus here you see 1 minus 1 plus lambda, so this becomes lambda equal to 0. So you have here 1 minus lambda whole cube minus 1 minus lambda plus 2 lambda, okay, equal to 0. If you solve these equations, expand it and solve it, you will get lambda values as 0, 0 and 3. Okay, you get 3 eigenvalues. When you have a 3 by 3 matrix, you get 3 eigenvalues 0, 0, 3, right? 3 eigenvalues 0, 0, 3. I think some of you might have solved, you got the same answer 0, 0, 3. Okay, now we got this. Now how do you find out the eigenvector? See, since 1 is repeating, you can find out eigenvector for 0 and 3 only. It is repeating means you can find it only for two values, 0 and 3. So let's try to find out the eigenvector using Cramer's rule. Can you tell me what are the eigenvector for eigenvalue 0? For the first eigenvalue, can you tell me what is the eigenvector? What is the eigenvector? For eigenvector for lambda 1, that is 0. So if you substitute 0, your matrix becomes 1, 1, 1, 1, 1, 1, 1, 1, 1. So this is your matrix. So if you multiply with 3 equations, x1, x2, x3 equal to 0, what do you get here? Yes, any guess? What are the eigenvalues? The same equations, right? Is repeated. We are having repeated values. So how do you find it out? One minus 1, 0. True, right? So again, if I want to solve this system of linear equations, if I can, even if you apply Cramer's rule, you may not get the proper solution, because you have 3 equations, x1, x2, x3. x1 equal to 0, again same, x2 plus x3 equal to 0. Even if I determine everything is 0, right? So here we have infinite number of solutions, right? So one way what you can do here, you can assume one value to be 0. Like I will say, I'll try to convert this matrix into apply row transformations. If I apply row transformations, I can make this matrix like this: 1, 1, 1, 0, 0, 0, 0, 0, 0. And I have this x1, x2, x3 equal to 0. Now, if I solve this equation, if I multiply this, I get x1 plus x2 plus x3 equal to 0. Assume x3 equal to 0. Then x1 equal to minus x2. x1 equal to minus x2. Right? So, maybe. So, we have infinite number of eigenvalues, eigenvectors. So, one vector, if you take 1, x1 as 1, if you take x2 as 1, it is minus 1, 1, 0. Or if you write like this, x2 equal to minus x1, you get here effect 1 minus 1, 0. This way you get n number of eigenvectors, correct? So this is one value. Now for lambda equal to 3, you tell, for lambda second eigenvalue 3, what is the eigenvector for eigenvalue lambda equal to 3? Try to solve and find out the eigenvectors. So this is for lambda 1 equal to 0. We want to find out for lambda 2, that is eigenvalue. So matrix becomes minus 2, 1, 1, 1, minus 2, 1, 1, 1, because I'm substituting lambda equal to 3. So it becomes minus 2 into x1, x2, x3 equal to 0. Maybe you can apply Cramer's rule here. You get one equation minus 2x1 plus x2 plus x3 equal to 0. Second equation, x1 minus 2x2 plus x3 equal to 0. Third one, you can take any first two equations is sufficient. So I will apply Cramer's rule here, x1, x2 and x3. Determinant I will find out. So I will take coefficients of x2, x3. So it is 1, 1, minus 2, 1. And for x2, when I take x2, I have to take for x1 and x3. So it is minus 2, 1, 1, 1. When I take x3, remaining 2. So it becomes minus 2, 1, 1, minus 2. Find out determinant. You get x1 value 1 minus 1 into 1, 1 minus means becomes 3. So it becomes 3. x2 minus 2 minus 1. So minus 3. x3. This is minus 2 into minus 2, 4 minus 1. This is 3. So you get 3 minus 3, 3. If you generalize it, maybe you can divide by 3. You get eigenvector as 1 minus 1, 1. Did you get this? 1 minus 1, 1 for lambda equal to 3. Right? So we got 2 eigenvalues, 0 and 3. We got 2 eigenvectors. Okay. So this way you can calculate, but in Python programming it's very, very simple. You can directly calculate the eigen values there, right? So you can calculate eigenvalues and eigenvectors. So we have seen this eigenvalue and eigenvectors. Okay. So